Hello friends, welcome to Physics by GD. Today we are going to solve the exercise number 11.3. So in this exercise you will find the function is defined in the interval 0 to pi. So in every problem the function is defined in the interval 0 to pi. So what is special about this function? So as you have seen in the previous two exercise 11.1 and 11.2, you would have seen the function was defined in the interval minus pi to pi or 0 to 2 pi. But here the function is defined in the half interval of that previous interval. Okay, so the function is defined in the half range. That is why we call this type of function as half range function, and the series corresponding to this function is called half range series. Okay, so for example, if suppose my function is x and it is defined in the interval 0 to pi. Okay, so the graph of the function f of x equal to x is something like this. So from 0 to pi, function is something like this straight line starting from the origin. So in this type of problem, we have to find the Fourier sine series or Fourier cosine series of the function. So while finding the Fourier sine series, I will consider function as odd function, and while finding the Fourier cosine series, I will consider function as even function. So why I am considering function as odd and even while finding the sine and cosine series? Because while finding the sine series, I am calculating the bn coefficient, Fourier coefficient, which is equals to 1 upon pi minus pi to pi f of x sin x dx. Now here the general formula for finding the Fourier coefficient was from minus pi to plus pi, but our given interval is from 0 to pi. So here what we consider, we consider some value of function in the left hand side, which is from minus pi to 0. We consider function as some value and we are not taking it into calculation. So here I am considering function as odd. So odd function into odd function will give me even function. So we know that for even function, minus pi to plus pi integral becomes 2 times 0 to pi integral. So in this way I am calculating function value from 0 to 2 pi, but it is getting double. So the Fourier coefficient will be multiplied by 2 times in the interval 0 to pi by considering function as odd or even. Okay, so let us start with question number 1. Find the Fourier cosine series for the function f of x equal to 1 in the interval 0 to pi by 2 and 0 in the interval pi by 2 to pi. So as I have told you, so we will be multiplying 2 to the previous formula. So previous formula was 1 upon pi minus pi to pi f of x dx. So here the Fourier coefficient a naught formula will become 2 upon pi 0 to pi f of x dx. So the function is 1, okay, in the interval 0 to pi by 2, and the function has value 0 in the interval pi by 2 to pi. So in this way my value of a naught comes out to be 1. Okay, so an is equals to 2 upon pi 0 to pi f of x cos nx dx. Again I have multiplied by 2 here, okay, by considering function as even. So an is equals to 2 upon pi 0 to pi by 2. Function is defined as 1 cos nx, and in other interval it was 0, so I am taking 0 directly. So n is equal to 2 upon pi integration of cos nx is sin nx upon n 0 to pi by 2. So sin n pi by 2 minus sin 0, which is 0. So the value of my an comes out to be 2 upon n pi sin n pi by 2. Okay, so my function f of x, so the Fourier cosine series of the function is f of x is equals to a naught by 2 plus summation n starts from 1 goes to infinity an cos nx. So the value of an, as you can see, for even value an comes out to be 0, because sine even value, which means 2 pi upon 2, which is pi, sine 4 pi upon 2, which is 2 pi. So in this, for even value of n, sine value will be equal to 0. So here you can see in this series there is no even term because even term is equal to 0. For n equal to 1, it will give me sin pi by 2, which is 1 plus 1. So cos x, cos 1x, 1 up, divide by 1. Okay, 2 pi I have taken outside and a naught was 1. So 1 by 2 plus 2 upon pi cos x upon 1. For n equal to 3, it will give me sin 3 pi by 2, which is minus 1 and divide by 3. So minus 1 upon 3 cos 3x plus cos 5x upon 5 up to infinity. So this was the Fourier cosine series of the function f of x which was given. So let us now move to question number 2. So here we have to find a series of cosine of multiple of x which will represent function in 0 to pi interval. So where function is 0 in the interval 0 to pi by 2 and it is pi by 2 in the interval pi by 2 to pi. And also we have to deduce that this series is equal to pi by 4. So let us start with calculating a naught. So a naught is 2 upon pi 0 to pi f of x dx. So the function is defined in the interval pi by 2 to pi with value pi by 2. Okay. So after solving this value, I will get a naught equal to pi by 2. So I am getting a naught equal to pi by 2. Now I will calculate an. So an is 2 upon pi by 2 to pi by 2 into cos nx dx. So I am taking pi by 2 common outside. So this two thing will cancel out, pi and 2, 2. So integration of cos nx is sin nx upon n in the interval pi to pi by 2. And we know that sin n pi is always 0. So 0 minus sin n pi by 2. So it will give me an equal to minus sin n pi by 2 upon n. So f of x is equals to a naught by 2, which is pi by 2 upon 2 is pi by 4. Minus, that I have taken this minus sign as common. So when sin n equal to, so when n equal to 1, it will give me sin pi by 2, which is 1 upon n 1. Cos x plus, for odd term it will, sorry, for even term it will give me 0. So 0. And for n equal to 3 it will give me minus, because sin 3 pi by 2 is minus. So minus 1 upon 3 cos 3x plus 0 plus 1 cos 5x upon 5 plus 0 minus cos 7x upon 7. Okay, up to infinity. So in this way my function is equals to pi by 4 minus cos x plus cos 3x upon 3 minus cos 5x upon 5 up to infinity. So as you can see, this series 1 upon 3 plus 1 upon 3, sorry, 1 upon 1 plus 1 upon 3 plus minus 1 upon 5 up to infinity. It is when I will remove the cos equal to 1, when I will convert cos theta into 1, I will get the series which I have to calculate here. Okay, so here I am putting x equal to 0. So at x equal to 0, function is equals to 0. So 0 equal to pi by 4 minus cos 0 is 1, cos 0 is 1, so 1 by 3 minus 1 by 5 up to infinity. So I am taking this whole term to the LHS. So I will get pi by 4 equal to 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 up to infinity. So in this way we have deduced that pi by 4 is equal to this series. Okay, so let's now move to question number 3. So question number 3 says that express function equal to x as a sine series in 0 to pi interval. So here we will calculate the Fourier coefficient Bn. So Bn is equals to 2 upon pi 0 to pi, function is x into sine nx dx. So the integration of x sin nx is x integration of sin nx, which is minus cos nx upon n, and plus, sorry, minus integral of derivative of x into integration of sin nx. So this will give me this thing. Okay, so after putting the limit I will get 2 upon pi bracket, so pi minus 1 upon n pi cos n pi, which is minus 1 to the power n minus x equal to 0, so 0, and this term will be 0 because sin n pi is 0 and sin 0 is again 0, so this will give me 0. So in this way my value of Bn comes out to be minus 2 upon n minus 1 to the power n. Okay, so f of x is equals to b summation bn n sin nx, so which will give me minus 2 upon n minus 1 to the power n sin nx. Okay, so f of x will be equal to, I am taking 2 common here, so I am taking 2 common here, and for n equal to odd term, this will give me minus 1. So minus 1 into minus 1 will be plus. So odd term will be plus and even term will be minus. So you can see sin x upon 1 minus sin 2x upon 2 plus sin 3x upon 3 up to infinity. Okay, so this was question number 3. So question number 4 is find the cosine series for the function pi minus x in the interval 0 to pi. So here we will first calculate the Fourier coefficient a naught. So it is 2 upon pi 0 to pi function which is pi minus x into dx. So 2 upon pi into x. So x 0 to pi will give me pi minus 0 minus x square upon 2. So 2 common and pi square minus 0. So after simplifying this term, I will get a naught equal to pi. Okay, now I will calculate an. So an is equals to 2 upon pi 0 to pi minus x cos nx dx. So I am splitting the integral pi into cos nx, x into cos nx. So the integration of this thing is equal to this thing, and the integration of this thing is this x sin nx n plus cos nx upon n square. So after substituting the limit from 0 to pi, this term will be 0 because sin n pi is 0 and sin 0 is 0. And this will give me again 0 because 0 to pi this thing is 0. So I will be left with minus 0 plus cos pi n pi, which is minus 1 to the power n minus cos 0, which is 1. So the value of an comes out to be 2 upon pi n square 1 minus 1 to the power n. So f of x is equals to a naught by 2, which is pi. So pi by 2. Here I am taking 2 upon pi common. So 2 upon pi is common. And for n equal to odd term, this will give me minus 1. So minus 1 plus. So for odd term, it will give me 2. And for even term, it will give me 0. So for odd term, all the odd term I am taking 2 as common. So it will become 4. So for cos n equal to 1, it will give me cos x upon 1 square, cos 3x upon 3 square, cos 5x upon 5 square up to infinity. Okay, so this was question number 4. So question number 5 is if f of x is equals to 0 in the interval 0 to pi by 2 and it is pi minus x in the interval pi by 2 to pi, show that this thing is equal to this thing and this thing is equal to this thing. Here we have two correction in both the part, first part and second part both. So in textbook or you reference book, you will find f of x equal to 2, it is given 4 upon pi, but here it will be 2 upon pi, and sin x minus sin 3x upon 3 square plus sin 5x upon 5 square, and this term is same, but here in book it is given 4 upon pi, but it should be 2 upon pi. Okay, and in second part you can see in textbook it is 4 upon pi minus 2 upon pi, but here 4 will be there, so 4 upon pi, and in bracket it is 1 upon 1 square cos 2x, but it is 1 upon 2 square, and here it is 1 upon cos 3 6x upon 3 square, but it is 6 square. Okay, and cos 10x upon 10 square. So please make this correction in the book. Okay, so let us start with finding the first finding this part, which is sine series. So bn is equals to 2 upon pi by 2 to pi, function as value pi minus x sin nx dx. So again I am splitting the integral pi sin x and x sin x. Integration of this thing is cos nx upon n, and integration of this thing is equal to this thing. So after substituting pi and pi by 2, I will get cos n pi minus cos pi by 2. Okay, minus bracket minus 1 upon n pi into cos n pi minus pi by 2 into cos n pi by 2 plus sin n pi minus sin n pi by 2 upon n square. So in this way, this term will give me minus pi upon n minus 1 to the power n minus cos n pi by 2, and it will give me minus minus plus, so pi upon n minus 1 to the power n minus minus will give me minus pi upon 2n cos n pi by 2, and this will be equal to minus sin n pi is 0, so 0 minus sin n pi by 2 upon n square. So bn will be equal to 2 upon pi minus pi by n to minus 1 to the power n plus pi by n cos n pi by 2 plus pi by n minus 1 to the power n and minus pi by 2 n cos n pi by 2 plus sin n pi by 2 upon n square. So you can see this two term will cancel out, and this is 2 time of this thing. So it will give me bn equal to 2 upon pi upon 2n cos n pi by 2 plus sin n pi by 2 upon n square. So my function will be equal to summation n starts from 1 goes to infinity bn sin nx. So for n equal to odd term, cos n by 2 n pi by 2 will be equal to 0, and sin n pi by 2 is nothing but plus minus 1. So for n equal to 1 it is plus 1 upon n square sin nx, n equal to 3 it is minus, so minus 1 upon 3 square sin 3x, and for n equal to 5 it is plus 1 upon 5 square sin 5x. I have taken 2 upon pi common here. So my final result will be equal to this 2 upon pi. Okay, so which we have to find. So let us now move to question number 2, which is here we have to find the cosine series. So for cosine series, first I will calculate a naught. Okay, so a naught is equals to 2 upon pi by 2 to pi minus x dx. So after solving this integral, I will get a naught equal to pi by 2. So an is 2 upon pi by 2 to pi minus x cos nx dx. Okay, so again splitting the integral, pi cos nx and x cos nx. Integration of this thing will give me this, and integration of this thing will give me this term. And substituting the lower and upper limit, so I will get sin pi upon n common, sin pi is 0 minus sin n pi by 2 minus bracket, we can see for pi it will give me 0, so 0 minus pi by 2n because pi by 2 and n, so pi by 2n sin n pi by 2 plus cos n pi, which is minus 1 to the power n minus cos n pi by 2 upon n square. So after simplifying this, I will get 2 upon pi minus pi by n sin n pi by 2 plus pi by 2n sin n pi by 2 and minus 1 to the power n upon n square plus cos n pi by 2 upon n square. So in this way you can see this term and this term, it is half of this term is half of this thing now. So it will give me an equal to 2 upon pi minus pi by 2n sin n pi by 2 minus of minus 1 to the power n upon n square plus cos n pi by 2 upon n square. So let us now substitute the Fourier coefficient a naught and an in the formula. So f of x is equals to, for here I am considering for n equal to even value, sin n pi by 2 will give me 0 and cos n pi by 2 will give me plus minus 1. So here I am considering n equal to even values. So for n equal to even value, this term is always 0. And for n equal to 2, it will give me minus 1, and this will give me cos pi, which is minus 1. So minus 1 is minus 2. So you can see minus 2 upon 2 square for n equal to 2 cos 2x. And for n equal to 4, it will give me again minus 1, and this will give me n equal to 4 is cos 2 pi, which is 1. So it will give me 0. So for n equal to 4 it is 0. And for n equal to 6, this will give me minus 1, and this will give me 3 pi, which is minus 1. So minus 1 again minus 2. So you can see minus 2 upon 6 square cos 6x plus again n equal to 8 will give me 0, and for n equal to 10 it will give me minus 2. So you can see. So I am taking minus 2 common here, so it will give me 4 upon pi minus 4 upon pi cos 2x upon 2 square plus cos 6x upon 6 square plus cos 10x upon 10 square up to infinity. So in this way we can show that f of x is equals to this thing by considering n equal to even. So this was our question number 5, in which two corrections were there. So I hope you have made that correction. So let us now move to question number 6. Question number 6 says that find the half range cosine series for function x square in interval 0 to pi. So first we will find a naught. So a naught is equals to 2 upon pi 0 to pi x square dx. So this will give me a naught is equals to 2 pi square upon 3. Okay. So an is equals to 2 upon pi 0 to pi x square cos nx dx. So the integration of x square cos nx dx is x square into integration of cos nx, which is sin nx upon n, limit 0 to pi, minus integration 0 to pi derivative of x square, which is 2x, into integration of cos nx, which is sin nx upon n dx. So again after simplifying this thing, I will get for 0 and pi, sin n pi is 0 and sin 0 is 0. So this term is 0, minus I am taking 2 upon n common here, bracket x, integration of sin is minus cos nx upon n 0 to pi plus sin nx upon n square. So after substituting the limit, I will get 2 pi into minus 2 by n minus pi by n cos n pi plus 0. So an comes out to be 4 upon n square minus 1 to the power n. So f of x is equals to a naught by 2. So 2 pi square by 3 divided by 2, which is pi square by 3, plus I am taking 4 common here. So 4 bracket n equal to 1 minus, so minus cos x upon 1 square plus cos 2x upon 2 square minus cos 3x upon 3 square up to infinity. So I am taking minus 1 sign common here. So it is giving me pi square upon 3 minus 4 cos x upon 1 square minus cos 2x upon 2 square up to infinity. So there is one correction in this problem also. So here in textbook it is given 4 upon pi, but here pi will not be there. So please make this correction also. So let us now move to question number 7. So question number 7 says that find sine series and second cosine series for the function e to the power x in the interval 0 to pi. So first we will find the sine series, and for finding sine series we will first find bn. So bn is equals to 2 upon pi 0 to pi e to the power x sin nx dx. Okay, so 2 upon pi, the general formula for finding this type of integration is e to the power ax upon a square plus b square into a sin bx minus b cos bx. So here a is equals to 1 and b is equals to n. So you can see limit 0 to pi. So I am taking 2 upon pi 1 plus n square common. So I will be left with pi e to the power pi bracket sin n pi is 0. So 0 minus n into cos n pi is minus 1 to the power n minus e to the power 0, 0 bracket 0, sin 0 is 0. So 0 minus n into cos 0 is 1. So n. So it will give me bn equal to 2n upon pi 1 plus n square into 1 minus minus 1 to the power n e to the power pi. So my f of x is equals to bn into sin nx. Okay. So second part is we have to find the cosine series. So cosine series is, for finding cosine series, first we will find a naught. So a naught is 2 upon pi 0 to pi e to the power x dx. So it will give me 2 upon pi e to the power pi minus 1. And an is equals to 2 by pi 0 to pi e to the power x cos nx dx. So 2 upon pi here I have taken common, e to the power ax upon a square plus b square into a cos nx plus b sin nx. Okay. So after substituting the limit and simplifying this thing, I will get an is equals to this thing. So my function is equals to a naught by 2, which is 1 upon pi e to the power pi minus 1 plus summation this thing an cos nx. Okay, so I am taking 2 upon pi common here, and I am taking minus 1 sign minus 1 again common, so minus 2 upon pi I have taken common here. Summation, it will be plus, so 1 minus e to the power pi minus 1 to the power n cos nx. So in this way we can show that f of x is equals to, this is cosine series and this is sine series for the function e to the power x in the interval 0 to pi. Okay. Problem number 8. So if f of x is equals to x plus 1 in the interval 0 to pi, find its Fourier sine series and cosine series, hence deduce that this thing is equals to pi and this thing is equals to pi square by 8. So first we will find the sine series. So Bn is equals to 2 upon pi 0 to pi, f of x is x plus 1 sin nx dx. Splitting this integral, x sin nx, so x sin x integration will give me this thing and sin x integration is equals to this thing. So after substituting the limit 0 to pi, it will give me minus 1 upon n common here and pi cos n pi, which is minus 1 to the power n minus cos 0 is 0 but x equal to 0, so 0 plus this term will be 0 because sin n pi and sin 0 is 0 always, and this is equals to minus 1 upon n cos n pi minus 1 to the power n minus cos 0, which is 1. So after simplifying this thing, my bn value will be equal to be 2 upon n pi 1 minus 1 to the power n pi plus 1. So my function will be equal to 2 upon pi bracket for n equal to 1. For, you can see, for n equal to even term, it will give me plus 1. So 1 minus pi minus 1. So 1 cancel out, it will give me minus pi. So for even term it is minus pi, minus pi, minus pi. And for odd term it will give me pi plus 2 because it will be plus and 1 plus 1 is 2 and pi. So pi plus 2, pi plus 2. For 1, 1, for 3, 3, for 2, 2 and for 4, 4. Okay. So this is the Fourier sine series for the given function. Now we have to deduce this relation also. So I am putting x equal to pi by 2. So at x equal to pi by 2, you can see function has value pi by 2 plus 1. So pi by 2 plus 1 is equals to 2 upon pi, and this comes out to be pi plus 2 upon 1, and this is the, and this is 0, and only odd term will be left, and this will give me sine 3 pi by 2, which is minus 1. So plus pi plus, so pi plus 2 into minus 1 upon 3, and in this way I will get pi plus the scheme. So to get, so to get this so to get this relation, I will put x equal to pi by 2. So this will give me f of x is equal to pi by 2 plus 1 at x equal to pi by 2, and it is equal to 2 upon pi. Here only odd term will remain and even term will be equal to 0. So this will give me 1, this will give me sine 3 pi by 2, which is minus 1, so minus 1 up to infinity. So I am taking plus pi plus 2 common here. So pi plus 1 equal to, so I have multiplied this here. So pi by 2 equal to pi plus 2 into this bracket term, which is 1 minus 1 by 3 plus 1 by 5 up to infinity. So this will give me pi plus 2 upon 2 into pi by 2, pi plus 2 and this bracket term. So pi plus 2 is cancelling out. So I will be left with pi by 4 is equals to this thing, which we have to show. Now I will find the cosine series. So for cosine series, a naught is equals to 2 upon pi 0 to pi x plus 1 dx. So it is 2 upon pi x square by 2 plus x 0 to pi. Okay, so a naught will be equal to pi plus 2, and an is 2 upon pi 0 to pi x plus 1 cos nx dx. So splitting this integral will give me x cos nx and cos nx. Integration of this will give me this thing, and integration of cos will give me this thing. So again, after substituting the value of simplifying the values, I will get en equal to 2 upon n square pi minus 1 to the power n minus 1. So you can see for n equal to odd term, it will give me minus 2, and for n equal to even term, this will give me 0. So you can see a naught by 2 plus summation of an cos nx. So for odd term it is 0, and even term it will give me minus 2. So minus 2 minus 2 minus 2, I am taking minus 2 common here. So it will give me pi by 2 plus 1 minus pi by 4 cos x upon 1 square plus cos 3x upon 3 square plus cos 5x upon 5 square up to infinity. So in order to get the relation which we have seen here, second one, so I am putting here x equal to 0. So at x equal to 0, function has value 1. So 1 equal to pi by 2 plus 1. So 1 cancel out, minus pi by 4 and this term. So in this way, pi square upon 8, I am multiplying pi square here. So pi square upon 8 is equals to this thing which we have to show. So the last question is question number 9. Find the Fourier series expansion of the function f of x is equals to cos sx minus pi to pi, where s is a fraction. Hence, show that cot is this equal to this series. Cot theta is equals to this series. So we will find the Fourier series of this function. So this is defined in the interval minus pi to pi. So we will follow this. So you can see here in this problem, the function is defined in the interval minus pi to pi. So we don't have to multiply by 2 to the formulas of a naught, an and bn. So let us start with finding a naught. So a naught is 1 upon pi minus pi to pi f of x dx. So 1 upon pi minus pi to pi, function is cos sx dx. So we know that cos sx is even function. So it will give me 2 times 0 to pi cos sx dx. So after solving this, I will get a naught equal to 2 upon pi s sin s pi. Okay. So an is equals to 1 upon pi minus pi to pi cos sx cos nx dx. So 2 upon pi 0 to pi, same thing. So cos sx cos nx 2 time is nothing but cos c cos d, 2 cos c cos d is cos c plus d plus cos c minus d. So it will give me an equal to 1 upon pi sin s plus nx upon s plus n plus sin s minus x upon s minus n. So n is equals to 1 upon pi sin s plus n pi by s plus n plus sin s minus n pi by s minus n. For 0 it will give me 0. So my function f of x comes out to be sin s pi upon pi s and summation this thing. So for sin n pi plus minus s pi is equals to minus 1 to the power n sin s pi. So if sin n pi plus minus theta is equals to minus 1 to the power n sin theta. So it will give me f of x equal to sin s pi upon pi, s pi plus summation n starts from 1 goes to infinity. So I am taking sin s pi which is common here and minus 1 to the power n minus 1 to the power n. So after simplifying this, I will get cos sx is equals to sin s pi upon pi s plus summation minus 1 to the power n sin s pi upon pi, and I have cross multiplied this two term. So after simplifying this, I am taking sin s pi upon pi common here. So 1 upon s plus summation 1 minus 1 to the power n and this bracket term. So it will give me 2s upon s square minus n square cos nx. So here I am putting x equal to pi. So at x equal to pi, it will give me cos s pi equal to sin s pi upon pi 1 upon s plus summation minus 1 to the power n 2s upon s square minus n square and cos n pi. Dividing by sin pi here, it will give me cot s pi. So it is equals to 1 upon s 1 upon pi 1 upon s plus summation this thing. So I am splitting this term. So it will give me cot s pi equal to 1 upon s pi plus summation 2s upon pi s square minus n square. So I am multiplying by pi numerator and denominator. So it will give me 2s pi upon s square pi square, which is s pi square minus n square pi square, which is n pi whole square. So for n equal to 1, it is pi square. So pi square. N equal to 2, it is 4 pi square and up to infinity. I am putting s pi equal to theta. So it will give me cot theta equals to 1 upon theta plus 2 theta upon theta square minus pi square up to infinity. So guys, this was our exercise number 11.3. So if you guys find this video helpful, so please like, share and subscribe.